So my name is Valkyrie Savage, and I'm working with Bjorn Hartman in the CS department and Paul Wright in the mechanical engineering department, and I'm here to talk about invention in high tech. So around us we see devices like the Nest thermostat and the Pebble watch, which communicate between the cloud and us via our mobile phones. So the Nest, you have an interface on your phone which you can use to control the temperature in your house, and the Pebble sort of displays things, information from your phone, so you don't have to look directly at it. This is an interesting model. You know, people enjoy making devices because computation and storage in the cloud is very cheap, and mobile access is an easy way to get from the swarm of devices sort of getting information about the environment to get that information into the cloud. So, but how do we design these devices? Of course, it's easy in an industrial context, but at Berkeley here, we built the Invention Lab to see if students can do it and if students would be interested in it. The Invention Lab had rather humble beginnings as an unused room in the basement of CITRIS, but it's grown into a respectable prototyping space. So we have everything from lo-fi prototyping supplies, soldering stations, we have a laser cutter, 3D printer, and even circuit board mills so that students can move from concept to product in any fidelity. Paul and Bjorn really wanted to share this space with students, so last semester they started the Interactive Device Design class. We attracted students from all over the engineering school. We had mechanical engineers and computer scientists, of course, but also electrical engineers and students from the School of Information, even bioengineering students. The course culminated in projects by teams of 3 students that followed the basic model I showed before of cloud mobile phone device. This was my team's project. We built an in-garden device for monitoring plant moisture, and it's hooked into a drip irrigation system so that you can basically check on your mobile phone or tablet how wet your plants are and change the drip irrigation so that they maintain the moisture that you think is ideal. This semester, there's actually 2 courses being taught in the CITRIS Invention Lab, one of which is the critical making class, which was mentioned before, and the second of which is the research extension of the interactive device design, which is again being taught by Paul and Bjorn. There's a lot of research to be done, of course, in the area of interactive device design, especially now that we have all of these exciting digital prototyping devices. My first project was focused sort of in that arena, and it was based on the idea that there are a lot of touchscreen devices around us, and prototyping when input and output are located in the same place is fairly simple. It's basically a software problem. But there are more and more devices showing up where input and output are not in the same place, where the input might be on the back of the device or on the back of your mouse. And here it becomes a hardware prototyping problem. So we built a system called Midas to help people realize designs where touch input is not co-located with output. To bring this sort of software model into hardware prototyping, we started with a drag and drop interface. So designers can drag and drop the representations of their sensors on a representation of their object, and when they're happy with it, they hit print. So here we generate a design file which is suitable for fabrication on a vinyl cutter, and we generate a set of instructions to help the designer assemble their object. The finished objects look something like this. So we basically feed conductive copper, adhesive-backed conductive copper through the vinyl cutter, which is easy to remove and replace on objects, and so prototyping and iteration cycles can be very fast. Moving beyond flat touch sensors, we're now interested in looking at 3D printers and how we can prototype using them, so that we can make things like video game controllers. Currently, prototyping for things like video game controllers is a very manual process. You might 3D print the body, but afterwards you have to solder all these parts together, you have to program a microcontroller. Wouldn't it be nice if it was easier? So we're looking at taking the 3D model before it's printed and making some basic modifications so that when the designer prints the device, all they have to do is insert a camera. And the camera can basically see the way that buttons are moving and sliders and dials and joysticks and all these things, and the camera abstracts away the sensing for you. So there's lots of exciting things going on in the Invention Lab, both research-wise and course-wise, and we've seen that students are very excited about it. I should also mention that we're looking for corporate participants so we can get more machines.